All right. So, all right. So let's start with, we have our patient who is, let's do a 25-pound dog. And dog. And we're going to do maintenance fluids, maintenance crystalloid fluids. And we want to figure out mils per hour and then drips per second. Okay. So what is our maintenance fluid rate? Let's start there. So we said that earlier. So it was 60 mils per kg per day, right? So how do we figure out so if we take 25 pounds, so 25 divided by 2.2 is 11.4 kgs. Let's go with that. So now what do we do?
11.4 kg times 60
Yes.
is 684 mils per day.
684 mils per day. Wonderful. Okay. So let's work that down to an hourly rate. Oh, 80.
So 684 divided by 24 would be 28.5 mils per hour.
684. So 80 or 28.5 mils per hour, right?
Yes.
All right. So now we have an hourly rate. All right. So now we have to figure out drips per second. Okay. So we have 28.5 drips. Oh gosh, look at me, 28.5 mils. All right. And now we have to figure out how many seconds are in an hour, essentially. Okay. So anyone know how many seconds are in an hour just offhand?
3,600.
Oh, good. Yeah, you're right. So 3,600. Yay. I'm like, somebody taught you this, huh? No. So how we figure that out is we have 60 minutes in an hour, in 1 hour. And then in 1 minute, we have 60 seconds. So if we put those two together, we have 3,600 seconds. So the reason why I just go ahead and put that right away is to stop confusing everyone with crazy dimensional analysis. Because that's why everyone hates these problems so much. So if we can just remember 3,600 seconds in this problem, we have 2 steps then to these drips per second. So we just take our mils and then we put 3,600 seconds because we just need drips per second. So we already have seconds here. Now we just have to figure out our drip rate, or I'm sorry, our drip set. So if we have an animal who is greater than 7 kilograms. We're going to use a macro set. All right, our macro sets are 15 drops per mil. If we have an animal who is less than 7 kilograms, we're going to use a micro set, which is 60 drops per mil. So our patient here is 11.4 kilograms. So what are we going to use?
Micro.
So we're going to use the one that's for greater than 7 kilograms.
Macro.
Macro set. So macro set has 15 big drops per mil. So 15 drops per ml. So how we know we did this right is that we are left with drops per second and cross out our mils. So that's the amount of dimensional analysis I can handle for myself. And now we can just simplify our math.
Does the micro set, is it the one that has the 60 drops?
Yes. So yeah, micro set is 60. Your macro set is 15 unless it says otherwise. Sometimes you'll run into them that have like 10 or 20, but the normal ones are 15.
Okay.
So I get 0.1 drop per second.
All right, so you have 0.118 drops per second. Some weird thing, right? All right. So now this is as far as the VTNE makes you go, right? So you're really lucky. But in real life, we can't do a decimal drop, as you guys know, right? So how do we get a whole drop in this case?
So we can multiply by a whole number to try to get something that can be administered. So you could take the 0.1 drop per second and maybe multiply by 10 in order to get 1 drop per 10 seconds. Is that right?
Okay. Okay. So we want to multiply by a whole number. You're correct, by a whole number, so that we get as close as possible to our mils per hour as we possibly can. So sometimes we might not be able to do by 10 seconds because it's going to change our mils per hour for our patient. So sometimes we'll have to multiply by maybe 6 seconds, 7 seconds, 8 seconds, 9 seconds to get to that whole number so that it gets us as close as possible. So if we take our answer, so 0.118, whatever it was, times how can we get as close to a whole number as possible?
.118 times 8 is 0.9.
Okay, try 9 seconds.
9 would be 1.
Okay, so we get 1 drop per 9 seconds. All right. Questions on that? All right, so let's do another one. Since there's so much fun. Let's see. We have a 12-pound dog who, let's do a fluid rate. Oh, you know what? I'll make you, let's do its head of starch dose. Head of starch rate. Figure out the mils per hour. And then, why don't you want to be there? And then drips per second as well. So what are the mils per hour and the drips per second? So where are we going to start?
Divide by 2.2.
Okay. So what is our kilograms?
5.45.
Good. 5.45 kilograms. And then what's our head of starch dose?
20 mil per kg per day.
Good. 20 mils per kg per day. So what do we get for this one?
$109 mils per day.
Good.
4.5 mils per hour.
All right, so we're going to divide that by 24. So you get 4.5 mLs per hour. Awesome. All right, so we have our mils per hour here. So how are we going to set up our for drips per second?
Divide by 3,600.
Great. So we're going to take our 4.5 mils, divide that by 3,600 seconds. And then what are we going to do from there?
Multiply by 15 drops per mil.
Okay, so we're going to multiply by a drip set. So remember, our drip set is that we are going to use the drip set for something that is less than 7. So we are going to use our
Micro.
So what is the micro drip set?
60 drops per mil.
60 drops per mil. Very good. 60 drops per mil. So we cross out our mils. We're left with drips per second. And we get 4.5. What do we get?
0.075.
Okay.
We
All
have to go
right.
greater than 10 seconds to get it to something we could administer.
We definitely do. So what are we going to multiply by?
$14 gives you 1 drop. I guess in 14 seconds.
Yep. Very good. Very, very good. That one was throwing me off a little.
Hmm.
I was like, 12, 13, 14 should do it. Very good. So that one's a good one that shows you too, because if you just changed it to 10 seconds, it would change your fluid rate too significantly for especially a small animal, where we do need to go that extra step. Maybe if you did it 1 drop every 15 seconds, it's not going to change it that significant. But if we were just a little bit too lazy and only just did 1 per 10 second and didn't do that extra step, we wouldn't be giving enough head of starch. So, or I'm sorry, we'd be giving too much head of starch. I lie, too much head of starch. So, so yeah, sometimes have to do a little bit extra to figure out our fluid rate. I know math is sometimes a little extra fun in that regard, where you guys are like, no, we don't like math. All right, any questions on that? Okay. Any other confusion that you guys have for math this week so far? We covered a lot.
So the people who are joining this class, do we still work in the old class, or do we just start on like week 1 in this class?
Just start where we currently are in this class right now, because we're kind of just, it's basically going to be the exact same thing. You, if you still want to work in the old class too, you absolutely can as well, because it's going to be essentially the same. So you have both to play in.
And we don't meet on Mondays now, we just meet on Sundays.
Correct. Yeah.
Okay, perfect.
Yep.
I didn't
It
want to
seemed like,
tomorrow.
yeah, and it seemed like this is going to work out in timing wise better for other people too. So kind of worked out nicely. So
I have a question about
Yeah.
something that we worked on. So the C1, V1, C2, V2.
Yeah.
The problems that we worked on, the volume went in the second part, the V2, I guess.
Yes.
But how do we know if the volume is going to be V1? Like, what would the problem tell us
Good question.
that we would know where to place things?
Yes. Great question. So if it said for you that you had like your 70% solution, like you have a 70% solution, and you're using 30 mils of that 70% solution, and you're looking to make a 7.5% solution, how much of the mils will you need? Like it'll say how much of the mils will you need for that to make that 7.5% solution. It typically will say like how much in the question, how much of that 7%, 7.5% solution. So it typically will say within that question, what will it be? So
that sounds like it'd be more like for not reconstituting drugs, but I don't know. I don't know how to say.
Normally you're not going to get, if anything, you're not going to get for a volume per se. You might get a percentage of for the V. For C2, you might get a C2 question. Like what is the C2? But it'll say like essentially what is the concentration or what is your final concentration of this, you know, product that you're making or whatever. So, but I can probably give you something better in a question when we meet again that is written out. But essentially, unless you're typically given a fluid, like a final product of what your fluid is versus what your,
Okay.
yeah, unless
Yeah, I
you're
think I went
adding a bunch
backwards
of,
the other way.
unless you're
Yeah.
adding a bunch of stuff together, you know what I mean? So that's kind of crazy, but
Okay,
yeah,
that makes sense.
typically you're not given something that's like that.
Okay.
Trying to think. They would have to try to be really tricking you in order to do that. Like in practice, you're not going to have something like that because that would just wouldn't make sense. All right. Next week, we're going to go over mill equivalents. Because I know that throws people off. So let me know if you have any questions on that. We'll go over again if you guys have questions again with like C1, V1, because I know that that is, you know, like that might ring a bell again, or if it might be confusing again if you had questions on that. Same thing with drip rates. If you get to some of those again and you're like, it made sense when we were doing it, but I still am being tripped up on when I'm doing it. Same thing with CRIs. CRIs are always tricky for people, so we'll do those again. So yeah, we'll go through some of those, and then we're gonna work towards doing some anesthesia end of things too. And then we're going to also get to doing some heart rate things, so calculating heart rates through ECGs and doing all of that. So a lot more fun things down the road. So you guys are doing great. This is really good work day. Very good. All right, any questions for me before we head out? Great. All right, guys, good job today. We'll see you all next week, of course. All right,
Thank you.
take care. Of course. Take care, guys.
Bye.
All right, bye-bye.